Okay, Q5, transformational functions. This is just putting everything together that we've been talking about and seeing if you have retained it and see if you get a better understanding of it. Okay, so we're find g of x, where g of x is the reflection about the y-axis. Remember, if we reflect about the y, we're just changing the x. So I keep the negative 3. I'm going to make the x negative, and I keep the positive 5. We're going to multiply here to get rid of the parentheses, and we get 3x plus 5, 3x plus 5. If I'm going to translate 2 units up, remember left and right, it's with the parent, and I put that in parentheses for a reason, because being with the parent, you're inside the house, right? And you always think opposite. Up and down, it stays true. So if we're going to go 2 units up, then we're going to add 2 to the 7. The negative 5 stays negative 5, and 7 plus 2 is 9. So negative 5 plus 9. Six units to the right. So to the right is inside the parent. If usually when you think right, we think positive, so we're going to go negative. So we're going to subtract 6 from the 10 that's already inside the parent. Everything else is going to stay the same. So 10 minus 6 is 4. Reflect about the y, so we're just going to change the x. The negative 8 stays, the 5 changes, the 7 stays. Negative, negative, positive. Okay, so it's an absolute value graph. We have to give the equation. So remember, absolute value usually starts at 0, 0. What happened? We went to the left 4, and we went up 4. Actually, let me put that in a different color since they're both the same number. Okay, so if f of x equals absolute value of x, because that's what that is right there, then g of x, the left 4 goes inside, but since it's left, we're actually going to do positive. Let me put that in yellow. That's that 4. Then up 4 is doing what it's supposed to do, and let me paint that blue. That's really supposed to be blue right there. Okay. Find g of x, where g of x is a reflection about the y, about the x. If it's the x, then we're reflecting about the y. If we're doing the y, then we're changing every term's sign. So 5 changes and 1 changes. We're going to go 1 unit to the left. That means we're going to be inside the parent. So to the left usually means negative, so we're going to do positive. We're going to distribute. We're going to bring that negative 10 down. This negative 10 is that negative 10. And then 10x, if I put these together, what's a positive 10 and a negative 10? 0, which means they cancel out. So 10x is going to go inside the box. Okay, on this one, kind of gave myself a little reminder because I got it wrong whenever I was actually doing the work. And so this is an absolute value graph. But what happens, and I haven't stressed this at all, but at the beginning, when we're talking about graphs, not the beginning of Q5, but like beginning of Q2 or something, I said on a normal absolute value, we'd go up 1 and over 1. And that's what the normal slope would be. Well, on this one, you got to kind of pay attention. And it did start at 0, 0. So it's not going to shift up, down, left, or right any. But it doesn't just go up 1 over 1 every time. So what I'm going to do, I'm going to follow that 0, 0 until, let me see, until it goes exactly through another corner, which would be this one right here. And so what would happen is I had to go up 9. It's basically slope, okay? So 9 over 7 to be able to get to the next point that it was there. So our equation, our g of x, you're going to put the 9 over 7 on the outside, and then there's that. Okay, on this, x squares usually start at 0, 0. This one shifted 7 to the left. Left is inside the parent, so it's not negative 7, it's positive 7. It didn't go up or down any, but that's what the equation would be. Okay. On absolute value graphs, I strongly suggest as soon as you see one, see if it, I really need it to be thinner. It's not going to be any thinner than that. Okay. See if you're going to go over 1, down 1 every single time, and you are. So you're not going to have to worry about that 9 over 7 or 3 over 4 or anything like that on this problem, okay? So basically what's happening is, was it shifted left or right? No. Was it shifted up or down? No. Different slope? No. Well, what happened? It reflected the x-axis. Why did it reflect the x-axis? Because this is the x-axis, and normally it would be right here, and it was flipped upside down. So what is the equation going to look like if that happens? The negative is going to be on the outside. Okay. So it's going over 1, down 1, over 1, down 1. Okay, so our slope here is still 1 over 1, so we're not going to have to change it any. Come here. Come here. Come here. Keep on going, keep on going. Okay, so the slope, different slope? No. Did it go to the left or right? Yes, it went to the right. 1. Did it go up or down any? No. And it also reflected x-axis, right? So what happens is the negative on the outside is the x-axis, and the x minus 1, x-axis, right 1, right 1. There's that. So you have to take everything into consideration whenever you see a graph and you're trying to find the equation. So again, let's just do this: left, right, up, down, reflect x, and slope. That's what you're going to have to take into consideration every time that you have an absolute value graph. So remember, it usually starts at 0, 0. Did it go to the left or right any? No. Did it go up or down any? Yes. Down. Let me just do something different. It went down 5. Did it reflect the x-axis? No, because it's still going up. And the slope, 1, 1. Oh, see? See, I see. Don't move. Come here. See, it looks like it's a 1-to-1, but it starts getting off course. It doesn't hit another point until right there. So the slope does change. What would it be? We'd have to go up 5 and over 6. So our slope is 5 over 6, which means the 5 over 6 is going to go on in front of the parent. And we're going to go down, so nothing's going to go inside the parent because it wasn't left or right. And we went down 5. Change colors. Left, right, up, down, reflect, X, slope. You have to think of every single one of those to be able to answer these questions. Did it go left or right any? No. Did it go up or down any? Yes. It went up 4. Did it reflect the X? Basically, is it going down? Yes. Slope, 1-to-1. Oh, it went off again because it's not hitting every single one. So if it's here, next one is here. So how do we get there? 4, that would be 6, and that would be 5. So 6 over 5. So 6 over 5 is the slope. Reflect X is the negative. Nothing's going to be on the inside because there wasn't a left or right shift, but it went up 4. So we have a +4 on the outside. Let me put some color to that one. Up 4, up 4. Kind of fun. I like them. That's it.